You are listening to The Vocal Technologist. Spoken tech for your ears.
Imagine finding out that an artificial intelligence coding assistant actually made your developers 19% slower.
Oh, wow. That is rough.
Yeah, it is. But the kicker is, those exact same developers confidently believed they were 20% faster.
It is just a massive cognitive blind spot. I mean, they genuinely felt like superhumans, but the literal stopwatch told a completely different story.
Exactly. And we have a massive stack of research to unpack to figure out why. We are pulling from open source benchmark tests, corporate engineering logs, and even hardware architecture manuals.
Right, because our mission is to look under the hood of that massive gap. The gap between what AI feels like it is accomplishing versus what is actually happening physically inside the servers.
Spot on. Because this illusion of speed is reshaping absolutely everything from browser security to the physical limits of global computing power.
Yeah, and if you are relying on these tools at work, you really need to understand the mechanics of what they are actually doing.
So to understand that reality, we have to pull apart how these models actually generate solutions.
Well, their biggest structural flaw right now is that they prioritize confidence over accuracy.
They just want to give you an answer.
Exactly. A language model is essentially, a massive people pleaser. It wants to give you an answer that looks structurally identical to a correct answer.
But it doesn't possess an internal logical compiler.
Right. It isn't actually testing whether the code will run efficiently. It just knows what good code is supposed to look like on the surface.
Which brings us back to those developers. There was a randomized controlled trial with 16 highly experienced open source developers.
And the results proved this structural failure right out in the open.
Yeah, they really did. The models optimize for plausible output that matches what you asked for rather than actually giving you correct code. Plausible being the operative word there.
Spot on. And when you are staring at a screen, filling up with text in 10 seconds, you aren't questioning the utility. You are admiring the speed.
Right, you just think, wow, look how fast I'm working.
Exactly. But let's look at an actual benchmark test. Someone asked a language model to rewrite SQLite in Rust.
Which, on paper, sounds like a pretty standard modernization task, right? People do that all the time.
Yeah, exactly. But the generated code ran 20,171 times slower on primary key lookups.
Wait, 20,000 times slower? That isn't just a minor inefficiency.
No, it is brutal.
If you deploy that into a production environment, your entire server architecture just falls over.
It is a fundamental collapse, and it happened because the AI query planner missed a very specific flag.
What was the flag?
It is called the DEK flag. That stands for is integer primary key.
Okay, so what does that actually do?
Well, in database architecture, the primary key is like the unique barcode on a product in a supermarket. If you know the barcode, you just walk straight to the exact shelf and grab the item.
So it is a targeted search.
Spot on. But because it missed that one single flag, the database engine didn't know it was looking at a primary key. Yeah, so instead of doing a quick targeted search, it sent every single query through a full table scan.
Wow. So it's like looking for a specific word in the dictionary by reading every single page starting from the letter A every single time you need to look something up.
That is exactly it. And that happens because the model recognized the syntax of a database query, but it completely lacked the underlying physical reasoning.
It knew the words, but not the physics.
Precisely. It doesn't know how a database engine actually searches for information on a physical hard drive.
Speaking of lacking reasoning, the same co-author who ran that benchmark shared another completely wild example.
Oh, the disk cleanup one.
Yes. An AI was asked to write a disk cleanup daemon. Literally just a tool to empty the digital trash bin.
Right.
It spat out a piece of software that was 82,000 lines long. 82,000.
Which is just absurd.
It gets weirder.
Oh.
It included a Bayesian scoring engine and a proportional integral derivative controller.
Wait, a proportional what?
A proportional integral derivative controller, or a PID controller.
That sounds incredibly over-engineered. A Bayesian scoring engine is a complex statistical probability tool used to predict outcomes based on prior knowledge.
Right.
It essentially built a high-end casino probability algorithm just for a trash bin.
Exactly. And the PID controller is the mathematical engine that keeps your car at exactly 80 kilometers an hour on the highway when you set the cruise control.
Oh, wow. So it constantly calculates the error between where you are and where you want to be.
Spot on. And the AI used all of that high-level industrial mathematics just to figure out if it should delete temporary files from a hard drive.
When a standard one-line cron job already handles that perfectly.
Exactly. It's like hiring an overly confident apprentice tradie who builds you this visually stunning multi-story mansion but completely forgets to install the plumbing.
That tradie analogy really gets to the core of the issue.
It looks amazing on the surface, but it is entirely non-functional for its actual purpose.
And these tools encourage us to admire the structure. That is why those developers in the trial felt 20% faster. The screen was filling up with code.
But then you have to spend days debugging an 82,000-line system you did not write and do not understand.
Yeah, it completely shifts your job from writing code to debugging an algorithm's hallucinations.
But here's a pivot that doesn't immediately make sense to me. If AI is writing 82,000 lines of absolute junk code, how are these same models becoming the ultimate building inspectors for complex software?
Well, spotting a crack in the foundation requires a very different cognitive skill than actually building the house.
Right, I guess that makes sense.
AI is currently vastly better at pattern recognition than it is at executing flawless sequential logic.
We see exactly this with Anthropic and their Claude Opus 4.6 model.
Yeah, the Firefox example.
Exactly. In just 2 weeks, this model discovered over 100 bugs in the Firefox browser codebase. 14 of those were classified as high severity.
Which is huge.
Just to put that volume into perspective, that is more bugs than the rest of the entire world typically reports to Firefox in 2 whole months.
Yeah, because when you point a massive neural network at a codebase, it can highlight anomalies and structural weaknesses with terrifying speed.
Because finding a bug is essentially just spotting a deviation from a safe pattern.
Exactly. That is pure statistics,
Yeah.
which is exactly what a language model is built to do.
Okay, I understand the pattern recognition part. But when the researchers asked the model to actually write the code to exploit those exact same bugs it just found, it completely failed.
It hit a wall.
Yeah, the exploits it wrote were easily blocked by Firefox and its other real-world security mechanisms.
Right.
It's like a brilliant guard dog that can smell an intruder from a mile away, bark its head off, but cannot figure out how to unlatch the gate to actually chase them.
That is a great way to put it.
Yeah.
Because writing an exploit requires strategic execution. It isn't a single command. It is a negotiation with a hostile environment.
Right, there is a back and forth.
Exactly. You send a payload, the host operating system memory protection blocks it. A human hacker sees that block, pauses, and thinks about how to bypass it.
They might pivot to a different vulnerability first.
Spot on. They chain things together. You have to write sequential logic, anticipate defenses, and adapt dynamically.
And that requires dynamic reasoning.
Which, as we saw with the Squatolite full table scam, is still a massive hurdle for these models.
Yet, companies are leaning hard into this bug-finding superpower anyway. OpenAI is pushing a similar concept with their Codex security application.
Yeah, it is designed to analyze massive repositories, identify high-impact vulnerabilities, and suggest fixes.
It shifts the burden of finding the needle in the haystack from the human to the machine.
But to bridge that gap between merely spotting a problem and actually executing a complex, secure solution, developers are having to fundamentally change how AI remembers and reasons.
Because you cannot execute a multi-step exploit if you cannot remember what the first step accomplished. And this brings us to a massive architectural pivot in the enterprise environment. Google has open-sourced something called the always-on memory agent under an MIT license.
And what genuinely surprised me here is that they are entirely ditching conventional vector databases.
Vector databases have been the absolute standard way to give a model memory for a while now.
Yeah. Think of a vector database like turning a whole book into a massive spreadsheet of coordinates.
Okay, I'm with you.
When you ask a chatbot a question, the system tries to find the numerical coordinates that match your question, grabs that specific paragraph out of the database, and feeds it to the model.
But it is fragmented, right?
Very. Sometimes it grabs the wrong paragraph, and the model completely loses the thread of the conversation.
So the always-on memory agent doesn't do that at all. Instead, it continuously ingests information in the background, consolidating it for persistent memory.
It is more like a human brain consolidating memories during REM sleep.
It reviews the conversation history quietly, summarizing and updating a persistent understanding of who you are and what you are trying to achieve.
Honestly, an agent that continuously consolidates information in the background probably has better long-term recall than I do after a big weekend.
Fair enough, mate. But structurally, this represents the transition from stateless conversational chatbots to persistent enterprise infrastructure.
Yeah. True reasoning requires an agent to pause, reflect on what the user actually wants, and maintain a continuous context window over long periods of time.
And researchers are actually proving that giving models this ability to reason changes the output entirely.
There is research showing that reasoning boosts search relevance by 15 to 30%.
And the trick isn't adding more complex neural layers, is it?
No, it's giving the agents simple, transparent tools like the grep command.
Just a standard command line utility.
Exactly. It searches plain text data sets for lines that match a specific keyword.
So why does giving an AI that tool make such a difference?
Well, when you ask an agent to use a simple tool like grep, it cannot just hallucinate an entire file at once.
Right, because it has to wait for the actual search results.
Spot on. It forces the model to stop, run the search, read the literal text that comes back from reality, and base its next action on that real data.
When you explicitly ask it to explain its intent after running that search, you force it to articulate the why before it executes the how.
It really exposes how an AI output is heavily restricted by its all-encompassing prompt.
We forget that the prompt forms its entire environment. The system instructions, the conversation history, the context files. That prompt is the universe the model lives in.
And if we want these models to operate safely in that universe, we have to shape how they explore it.
Right, which brings up reinforcement learning.
Yeah. Shaping the exploration of the motivation space is now seen as absolutely critical for AI safety.
Because if you do not guide what motivates the agent, you risk harmful misalignment.
Exactly. It might decide the absolute most efficient way to achieve its goal of cleaning up your disk drive is to just delete the entire operating system.
Which would clear up heaps of storage space, to be fair.
It would.
But it's definitely not ideal for the user. But developers are iterating on these reasoning loops heaps fast. Andrzej Karpathy open-sourced a project called Auto Research.
Oh, that one is brilliant.
What does that do?
Well, it allows these agents to run research loops, modify their own code, and iterate improvements completely overnight.
Wait, on massive servers?
No, that is the crazy part. On a small, single graphics processing unit setup, a single GPU.
Oh, wow. So you do not need a massive corporate server farm to have an agent testing and improving itself while you sleep.
Exactly. It democratizes the whole research loop.
But bringing this back to the enterprise level, giving these agents persistent memory and advanced reasoning capabilities sounds brilliant in theory.
Yeah, but the problem is strictly physical.
The physical toll is massive. All of this continuous background thinking, the memory consolidation, the reasoning loops, it requires a staggering amount of computing power.
And the world is genuinely struggling to provide it right now.
We are in the middle of a massive compute crunch. Anthropic has actually had to degrade services for users due to unprecedented growth and soaring demand.
The demand is completely outstripping the physical supply of silicon and electricity.
We cannot simply code our way out of a compute bottleneck. We are hitting the physical limitations of software.
To solve this, the industry has to fundamentally redesign the hardware architecture to support the massive data pipelines these reasoning models require.
We are seeing massive traction for SRAM-centric chips from companies like Cerebras and Grok, specifically for AI inference.
Yeah, because traditional graphics processing units rely heavily on DRAM, dynamic random access memory.
DRAM is dynamic, meaning it constantly needs a jolt of electricity just to remember what data it is holding.
Exactly. These new chips use near-compute memory architectures to minimize latency and increase throughput.
Okay, let me try to unpack the physical difference between SRAM and DRAM using a classic Aussie pub analogy.
Let's hear it.
Think of DRAM like keeping all your beer kegs down on the pub cellar.
Right.
Every single time someone orders a pint, the bartender has to walk all the way down the stairs, fill the glass, and walk back up.
Which takes forever.
Exactly. You have huge capacity down in that cellar, but fetching the data is a massive physical bottleneck.
And that is exactly what happens when you have billions of parameters to calculate. You are constantly running up and down the stairs.
But SRAM, static random access memory, is like having the kegs sitting right there on the bar next to the taps.
Yeah, you do not have as much total storage space right on the counter.
But pouring the pint is nearly instantaneous because the data doesn't have to travel anywhere.
That is a great analogy. In AI inference, managing that trade-off between memory bandwidth and compute capacity is absolutely everything.
Generating a response has two distinct phases, doesn't it?
Yeah. The pre-fill phase, where it reads your massive prompt, and the decode phase, where it generates the answer word by word.
And SRAM chips allow the model to absolutely fly through that decode phase because the data is sitting right there on the bar, not down in the cellar.
Spot on.
But the fact that we have to fundamentally redesign global hardware architectures just to keep up with these reasoning models brings us to the human cost.
Yeah, it really does.
As the hardware shifts and the software becomes more autonomous, the actual human beings building and managing this technology are facing a radically altered corporate environment.
It is reshaping the entire structure of the tech workforce. We are seeing AI-enabled startups operating with 40% smaller teams right out of the gate.
And despite having 40% fewer people, they are simultaneously raising much larger seed and Series A funding rounds.
Because investors are rewarding what they call massive headcount efficiency.
Which is just a very polite corporate way of saying we need fewer humans on the payroll.
It really is. The technology is allowing smaller groups of humans to do exponentially more work.
If you have an agent doing the baseline work of 10 junior developers, you do not need to hire those 10 junior developers.
You just need one senior developer to review the output.
Even the massive tech giants are quietly streamlining the creation process for individuals. Meta silently launched the Vibes AI editor.
Yeah, it is a standalone creation studio with project creation and timeline editing.
They are giving creators an entire production suite powered by algorithms, though word on the street is the output quality still needs a fair bit of improvement.
We're seeing this deep integration happening at the enterprise level, too. Anthropic launched the Claude marketplace.
What does that do for businesses?
It allows organizations to spend their existing Anthropic financial commitments on partner tools like GitLab and Snowflake.
So it embeds the models directly into the corporate workflow.
Exactly, making the AI a foundational part of the business operations rather than just some external tool.
But there is a serious tension building inside these companies regarding what this infrastructure is actually being used for.
Yeah, OpenAI hardware and robotics executive Caitlin Kalinowski resigned following reports of the company partnering with the Pentagon.
And look, we are just reporting the facts of the internal corporate dynamics here. We do not take any sides on defense contracts or anything like that.
No, absolutely not. It just highlights deep internal tensions regarding those contracts.
Right. It is just about conveying what is in the engineering logs and corporate reports.
Exactly. When you have top-tier engineering talent, they have options. And we are seeing that talent actively reconsider their roles when the application of the technology shifts into the defense sector.
It is a profound moment for the industry. You have models writing 82,000 lines of junk code, finding over 100 severe bugs in major browsers, consuming so much electricity we need entirely new microchips, and causing corporate teams to shrink by 40%.
It really forces us to ask what the actual goal of all this acceleration is. If you are the one senior developer left on a team that used to have 5 people, you aren't writing code anymore. Your entire job is reviewing the output of autonomous agents.
Are we building robust infrastructure or just using supercomputers to generate plausible outputs?
That is the big question.
Which leaves us with one final fascinating provocation to mull over. If we are currently filling the world's software repositories with millions of lines of overly complex Bayesian-scored junk code, what happens when the next generation of AI uses that exact same junk code as its training data?
Are we poisoning the very well we're trying to drink from?
Exactly. Something to keep in mind while you check the plumbing in your own code base. Thanks for listening to Vocal Technologist.
Spoken Tech for your ears.